All right, so today is yet another overstatement, but in this case, I'm going to claim that patching. Who's doing patching? And I'm going to argue we don't need no stinking patching, right? And so in the cloud anyway, and this is like one of the hardest things to get right when you move out of a data center is the fact that the systems that you have should no longer be near and dear to your heart, and they should be infinitely replaceable products, kind of like some companies treat their employees. So what do we mean by patching? Updating parts of an operating system on a running VM, right? So if we got some running virtual machine or real machine, we're going to update it in place. And nobody's using physical hardware in the cloud anymore for like very few things. Those few use cases, we're going to close our eyes or put blinders on and we whistle past as we walk past the graveyard, right? We just don't want to know about it. So in this case, another one is updating tools on a running VM, not the operating system itself, but the tools that are installed. I would argue that we can do this in some cases, but it is a bad idea, and you should always have the ability to update those tools just through a redeployment or some other mechanism. Some patching will occur, but we'll talk about it, right? And updating the components or libraries in a running container, this is actually super difficult. And the fact that the container makes it difficult means we typically do container updates. This would be like a Docker, Kubernetes, some other kind of container. And then updating binaries in a deployed application. We almost never update just the binaries of an application that we custom built, right? And so it makes you wonder why any of these are different from each other. They all are basically a case where we have dependencies at some layer, and those dependencies need to be updated. And I'm going to argue that this should not happen. You should just say no. And people that want to do patching, why should we avoid this? Patching is the enemy of shift left, right? Patching implies that there's a division of labor between the team that deploys something and the team that actually builds it, and those are usually the same, and the team that actually maintains it. It is the enemy of you build it, you own it. Oh, I should change that. I'll put it in the slide later. It breaks a repeatable process with a deterministic result, right? So if I deploy something last month and then I patch it through the next year and I tear it down and I rebuild it next year, did I actually get the same thing, right? The new one would be on a new version of the operating system. I use the operating system as an example. If I take a 3-year-old unit and I keep patching it, I've got 3 years of patching applied. If I were to destroy that unit and replace it with a new one, that one would be subtly different because the patches had never been applied to it. So there will be subtle differences on those. The thing about patching is it really treats systems like pets, right? I know their name, I'm going to patch this system, the system never goes down, blah, 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 right? It's a pet versus cattle thing, and no, I don't know a vegetarian version of pets versus cattle. It's like, I don't know, perennials versus annuals. Maybe that's it. It's a perennial versus annual. Oh, maybe I'll go with that. All right. And the other thing is a lot of times you'll end up with these patch systems that are actually clusters. It's a compute cluster. It's a data cluster. It's something. It's a bunch of machines. And over time, we added capability to that. We started with 1 machine, and we went to 2, and we went to 5, and we became heroes, and we went to 20. And all of those machines were built at different times, and all of them were deployed with different versions of the operating system, and all of them are patched with different sets of patches applied, even though in theory they're exactly the same. And so you end up deployed on different base images. To me, that's just dumb. Just deploy the new ones, tear down the old ones, bring up the old ones again as a redeploy, and boom, everybody. And you know how you see this? I got a cluster of 42 machines, and one of these is different, right? If we don't patch and we don't fix, we just kill it and rebuild it, and we see if that fixes it. Yeah, triage by death. Man, that doesn't sound good. All right, and not all component tiers support patching. So why would we patch? It means we take different security posture, different behavior, depending on the pod we're in, the level we're at, right? I patch the operating system, but I don't patch the binaries on that for my application. That seems weird, right? So, treat it the same up and down the stack. The only thing that's different is possibly persistence and the size of the thing you're doing, right? And this is my main one right now. Man, if I patch stuff and I've got an infection or any type of malware or anything else that's leaked onto that box, man, it might survive my patch cycle and I won't know. If I tear everything down and rebuild it, as long as the deployment hardware is in place correctly and protected, then I've guaranteed to eliminate now somebody will post a case where it didn't happen, but I'm going to argue one of the big advantages of redeploy is you remove anything that got on there by accident, deliberately or not deliberately, but then it wouldn't be an accident. Anyway, you get what I mean, right? So the goal here, there are a bunch of reasons to avoid patching, right? Why do teams like patching? Someone else's problem. I did a whole talk on this. Some SCP. It's not my problem. I'm a development team. I only do releases for functional things. That patching thing isn't my problem. Well, you know what? With shift left, with DevOps, it's supposed to be your problem. And if you don't want to learn how to do patching, the easiest way to do this is just do a redeploy. They didn't fund to maintain their apps. You see this all the time. KTLO is an anti-pattern, in my opinion. Keep the lights on. It's basically, sometimes it's where people route money from their maintenance budget into new projects, right? But a lot of times it's just because nobody's maintaining a system and they're just hoping it'll run until they don't need it anymore. And to my mind, that's not really what happens. What happens is you throw it over to the operations team and they end up owning it because they do all the patching. And that's how you end up with, a 15-year-old operating system deployed on old hardware because nobody wanted to do an update because they didn't want to fund it. And so this to me is an anti-pattern, and then you deserve the ransomware attack that you got because you did everything possible to enable the enemy of your company. And why else do people like patching? They don't have to automate infrastructure as code. They don't have to automate deployments. I got this thing out here last year, man. We're just going to not touch it and leave it there till I need to update it. Bad. And then they don't have to think about how complicated their provisioning and deployment. This is another view on infrastructure as code or automated deployments. Man, we hand jam this thing in there and we hand jam it once every 6 months, and the patching team will take care of that thing, and we just kind of turn away from it. And as long as we don't look at it, it's up. And I'm going to argue that's just dumb. It's a bad idea. Yeah, it works for you now. And then we end up with these really weird dark corners in the company. So what do we do instead? We automate all provisioning and deployments. We move to real automated deployments. Not I wrote a script that a person runs. We move to real infrastructure as code. Look, the beauty of the cloud is it lets you do things you couldn't do before, right? If you're in a data center or at a provider where they have to wheel a machine up to make something happen, you bought in the wrong place. But if you can do infrastructure as code, that means you can go anywhere from the bottom, networking, routers, virtual machines, container management, PaaS services, containers, binaries. The whole way up is automated. And that means you can tear any piece down and bring it back up. I've worked places where our non-prod environment actually got destroyed on a regular basis and rebuilt from infrastructure as code. We can read, and what happens is we redeploy from CI/CD using infrastructure as code or whatever, and the patches are applied in the base images, and so no patching is done, right? Somebody tests the images, they build the base, we rebuild the app, we run it through the automated tests, you do have automated tests, and then we deploy it. No big deal. Some places, it's super easy. If we kill a running instance, it automatically gets brought back with the current patches applied, right? The base image this thing was built on actually comes back. That doesn't always work, but some places you can make that work. And the other one thing to do, we move to serverless. Just get rid of anything with a container. And serverless is always rehydrated anyway. So every time you get anything with serverless, you're going to be on the latest of whatever level that's at, whether it's an operating system or container system or whatever. And you just don't have to worry about it. You make it someone else's problem. It's not your problem. So what's the plan? Make it possible. Create base images, create base operating systems that you trust. Create them on a regular cadence. Hey, I'm going to create a new operating system every 3 months with all the base patches applied, and we're going to test it, and then everybody's just going to redeploy on that image within a certain amount of time. Approve PaaS and serverless. Don't do fake serverless. Oh, I did serverless, but I manage all my own images because I don't trust my cloud provider. Well, you know what? Get a new cloud provider. Find somebody who actually understands security and makes the keys work and all that stuff. There's a couple out there that are pretty good, right? And then you're going to query all, we're going to query all the running components to actually, oh, that belongs in the other one. You know what, skip that one. And like a place I was at, we did an inner source model. We actually did infrastructure as code as inner source. We tried to make it easy for people to add their automation capabilities. And so that was an enabler. And then the last part is we're going to enforce it. We're going to run some automated enforcement agent. The enforcement agents are going to generate an aging report. They're going to generate a version report. And then we go and feed that back to the teams. We give them a certain amount of time, and then we just tear it down if it's too old. In prod, that's a little difficult, but you start tearing down people's other environments and they get grumpy and they'll take care of it. So what about persistent data? Man, that's the one place we have a problem. In that case, we can't just kill database servers with persistent state. Actually, it turns out we can in some cases if you have the right provider. You have externally mounted drives in the cloud, externally mounted storage, and you can just kill the instance and it'll come back, mounting that thing back up with the patches applied if you do it right. And I would say move to RDS and other PaaS data systems. So RDS is the Amazon version, but anybody who's got a data store, a PaaS data store, just make it their problem. Wash your hands of it, right? And then the other thing you can do is you can do automated node replacement. If you're in a big enough cluster environment, a lot of times you can just start deleting components and they'll get brought back with a later version, or you can do a rolling upgrade, that kind of thing. This is the main area that's a problem, though, is persistent data. And what I'm saying is find a product that works. You don't have to do patching, or you figure out some way to do a rolling upgrade where the replica counts make sure you don't lose any data and you just kind of roll through a new deployment. They're sort of like patching, but I don't know. The databases are the only hard part of this, in my opinion. And so what about desktops? Totally out of scope. Although some people are smart, they do that. They move to a Chromebook or a thin client and they get out of the patching business, right? Because they don't have any apps installed. Well, they might still have the Chrome OS or something to update, but those updates are more automated and they just happen, and you have way fewer components installed, so basically thin down the desktops. And so that's it, really. Our goal should be ending in-place patching in our lifetime, make it configuration and code driven to get the environments that we need. Protect yourself from security risk by just deleting the components on a regular basis, or help protect yourself. And only you can make the world safe from patching. Have a great day.